Okay, so we have some extra questions. I put like little hints here. So if you wanted to print out this solution, that kind of helps you what you need to be thinking about. So when they're asking you what the probability is of x being greater than, less than, in between, whatever, you're going to have to use the z-score formula. So they give you a mean, they give you a standard deviation, and then they give you an x. So the z-score formula says z is, and we're just going to make it greater than, because it says greater than in the parentheses there. Z is greater than the x minus the mean divided by the standard deviation. So we want to know the probability of the z-score being greater than -2. So we would go to our probability table, and we would look up where -2 is. -2 on the chart has the number 0.0028. But remember, greater than is on the other side of the chart, so the chart is always based on less than. So when it asks you for greater than, you have to find the complement. So the complement to that number, it's 1 minus this. So 1 minus 0.0028 is going to give you 0.9772. And you can leave it as a decimal. I don't need percent, so you can leave it as a decimal. Okay? In the next one, it's asking for what the probability is for z being in between, or x being in between those two numbers. So you're going to do the same thing. You have to find the z-scores. Okay, so you have two z-scores to find. So 34 is less than 37 divided by 3 is 1. And I get -1 for that. And then the other one is 38 minus 37 over 3 again is 0.33. Remember, we're rounding these to 2 decimal places because our z-score chart is by 2 decimals. So we're looking, again, you have to go to the z-chart. I'm going to pull out -1 is 0.1587. 0.33 has a z-score probability of 0.6293. And we are going to subtract those. Anytime you're in between two numbers, you subtract them. So if I were to subtract these, I would get 0.4706. Okay, you are subtracting this. All right? So the z-score formula, very easy formula. You're getting the formula. Just remember, you then have to go to the chart, pay attention to if it's greater than or less than, or if it's in between. In recent year, the MCAT total scores were normally distributed with a mean of 500 and a standard deviation of 10.6. Find the probability that a randomly selected student scored less than 489. So this is just a word problem of what we just did. So they're asking for the z-score that is less than 489 minus the mean divided by the standard deviation. So that z-score, after you put in your calculator, is -1.04. They want less than, so we're just going to go to our chart and find the corresponding probability, and you're done. So is that unusual? No, it's not. It's only unusual if it's less than 5%. When the probability is less than 5%, then we say it's unusual to fall into that category. Okay? All right, in a survey of women ages 20 to 29, the mean height was 64.2 inches with a standard deviation of 2.9. What height represents the 95th percentile? So they're giving you, this is the same thing as if I were to write it that way. The percentile is 95. So you need to go to the z-score chart. That is a probability. So you're looking for 0.9500. Keep in mind, if you're in between, if it splits it pretty evenly, you have to do the two z-scores divided by 2. So when I go to the chart and I find a 0.95, it's in between 2. So the z-score that it represents is 1.645. That's the z-score. And then you have to find your x. So So it's the same formula we were just using. They're giving you something to find the z-score, and then you're going to plug it in and find your x. And you're going to cross multiply and all that fun stuff. You should get 68.97 inches, so I'm going to round that to 69 inches. The heights are by 0.1, so if it rounds, it's going to round it to a whole number there. Okay? When they give you a percentile, that is a probability. You're looking at 0.9500 in that chart, and then finding the z-score. All right. Number 4, you want to estimate with 90% confidence the population proportion of U.S. adults who eat fast food 4 to 6 times a week. Your estimate must be accurate within 3% of the population proportion. In a prior study, it was found that 11% of the U.S. adults eat fast food 4 to 6 times a week. Find the minimum sample size needed. So you have 3 sample size formulas. One has a population standard deviation, one has a sample standard deviation, and one has a population proportion, the p-hat and the q-hat things in it. So this one is on population proportion. So you need to use this formula. Sample size equals p-hat times q-hat, confidence level over the error. So the error is where it says within, it must be accurate within a certain amount. That's your E. And then that is squared. So our p-hat, sometimes they don't give you one. If they don't give you one and they say, hey, there's no prior knowledge found, you're going to use 0.5 for both p-hat and q-hat. But they did tell you in a prior study, it was found that 11% of U.S. adults. So that's the p-hat. So if p-hat is 0.11, or 11%, q-hat is the complement of that. So that would be 89%, or 0.89, times our confidence level. They're giving it 90% confidence. So remember, those are on your Z chart down below. So at 90% confidence level, it is 1.645 divided by the error that it has to be within, 3%, squared. So you put that in your calculator. Remember, minimum sample size, you've got to pop that up to the next whole number. So you need to interview at least 295 adults. Okay. A government agency reports a confidence interval of 26.2, 30.1 when estimating the mean commute time in minutes for the population of workers in a city. Find the sample mean and the estimated margin of error. They're giving you the answer, the interval. You've got to find the mean, which is going to be smack dab in the middle of it. So what is the midpoint here? So just add them together, divide by 2. So the mean is going to be 28.15. And then you need to find out what the error was. Well, how far away is that from 30.1? Or the other way, it doesn't matter. So when I subtract that, I get an error of 1.95. Okay. That's kind of like just one of those basic questions. From a random sample of 64 dates, the mean record high daily temperature in Chicago area has a mean of 84.13. Assume a population standard deviation is 14.56. Construct a 90% confidence interval for the population mean. They gave you the population standard deviation. So you're going to write the formula with the E, with the theta or the omega in it. Okay? Which is your confidence level times omega divided by the square root of n. So make sure you are familiar with what formula you have to use. That's the hardest part. So they're telling us a 90% confidence level. So we're going to go to our z-score chart. 90% correlates with 1.645. The standard deviation that they gave me for the population is 14.56 divided by the square root of 64. So my error, my margin of error is 2.99. So that's what we're going to add and subtract to our mean that they gave us. So when you add and subtract that to the mean, let's move this little guy over here. You're going to have an interval of, so 84.13 minus 2.99 is 81.14. And if you add it, it's 87.12. Now, why am I rounding 2 decimal places here? Because they gave me the degrees in 2 decimal places in the problem. So round how they give the answers in the problem, or the problem's parameters. Okay? In a random sample of 8 people, the mean commute time to work was 35.5 minutes, and the standard deviation is 7.2 minutes. So they gave you a sample standard deviation. This is a sample. Okay? So you're going to use the formula that has an S in it. So if it has an S in it, we need to use our T-chart. So I go to my T-chart, and I'm looking for the 95% confidence with a degree of freedom of 7. Okay. So when you're looking at that, the degree of freedom 7 and the confidence interval is 0.95. You've got 2.365. The sample deviation was 7.2 divided by the square root of 8. So you get 6.02. So I'm really just going to add 6. Okay? Rounded to the 10th because, again, that number was rounded to the 10th. So our interval is going to be 35.5 plus 6 puts me at 41.5, and 35.5 minus 6 gives me 29.5. So pay attention to what they're giving you. Standard deviation, is it population or is it sample? Or did they not give you one? Maybe they gave you a population parameter instead. Okay? All right, in a survey of 2,241 U.S. adults in recent years, 1,322 say they have made a New Year's resolution. Construct a 95% confidence interval. So right here, they did not give you any standard deviation. They didn't even give you a mean. You have to find your population proportion. So this is a p-hat. So our p-hat formula for the error is, you're back to the z-score, confidence level, and then it's the square root of p-hat times q-hat divided by the sample size. So that's our formula that we're going to use. First thing we have to do is figure out what our p-hat is. So we've got 1322 divided by 2,241. So 0.59 is that sample mean. And then we go down here, the population, the confidence interval is 95%. From your z-score chart is 1.96 times the square root of p-hat. Q-hat is the complement of that, which would be 0.41, divided by the sample size is the total, not just the ones that said they have made a New Year resolution. So it's got to be the total. So you get 0.02. Okay? That's what you're going to add and subtract to your mean. So 0.59 minus 0.02 is 0.57. 0.59 plus 0.02 is 0.61. And they want you to interpret the results. They basically say, listen, with 95% confidence, I can say that a sample mean will fall within that interval. Okay, with 95% confidence, I will say that any sample size or whatever I pick, the sample mean should fall within that interval. Okay, the hypothesis testing. So I gave you some clues here. The first thing you need to state the claim mathematically. Is it greater than, less than, equal to, greater than or equal to, whatever. Then state which one's alternate and the null hypothesis. Remember, the null hypothesis always has the equality in it. Determine which formula to use based on whether the population standard deviation was given or just a sample. If you want to use p-values, find the area that corresponds to the z-value from your chart. If p is less than the alpha, then you can reject the null. If you're going to use the critical regions, figure out the critical values using the significance level in the table. If your z-score is in the rejection region, you reject the null. So a couple different ways you can do this. We'll go ahead and do them both ways just so you see what I'm talking about. An education researcher claims that the mean high school graduation is 80%. So the claim is the mean is equal to 0.8. Right? So since there's an equal sign, the null is the mean is equal to 0.8, and the alternative is the mean is not equal to 0.8. Right? So it's either equal to or it's not equal to. All right. So you find the sample of 30 states has a mean high school graduation rate of 82. Assume the population standard deviation is 5.1. At alpha being 0.05, do enough evidence to support the researcher's claim. So what we are going to do is find our z-score first. So 0.82 minus 0.8. So it's always the sample mean minus the hypothesized mean. So what your claim is, divided by we have the standard deviation, divided by the square root of the sample size. Keep in mind, we are using the z-score chart because, we'll see there, we're using the z-score chart because they gave us a standard population standard deviation. So we're going to use that standardized chart. Okay, the z-chart. So I get here 2.148. That's my z-score. So I can place that on my bell curve. So 2.148 is like here. Right? Now let's figure out what our critical value is. I'm going to do the region thing first. So my critical value, I'm at 5%. And again, on my z-score chart, if I look at that, you're going, it's a right tail test. So 5%, top 5% is 95% confidence. So that's 1.96. So 1.96 is here. So anything to the right of that is going to be rejected. So this is my rejection region. And my z-score is right inside that rejection region. So I would say I'm going to reject. I have enough evidence. You have enough evidence to reject the null. Okay, and since our null is our claim, I'm going to go ahead and write the claim here. You have enough evidence to reject, so I do not have enough evidence. To support that claim. All right, now, if you want to say, I reject the claim, I get it. Just make sure you understand. The null hypothesis is not always, I want to do that. The null hypothesis is not always the claim. So make sure you have that marked somewhere. Okay, got to have it marked. Okay, now we're going to do it real quick with the p-value, because some of you like to do it that way. I just think it's easier to do it this way. So p-value, you're still going to find all this stuff. When you get to your z-score, you know that it's to the right, which means greater than. So we have to go to 2.148 on our chart. 2.148, let's do a 2.15. 2.15 has a probability of 0.9842. But remember, 0.9842. But we're talking greater than, so we have to do 1 minus that. So we're looking at 0.0158. That is less than my significance level. Therefore, I reject the null. So that's the only difference. Instead of going by our z-scores and placing them on the curve and looking at regions, you're actually going to find the probability, the actual probability, and compare it to the significance level that you've set. Okay? If it's less than the significance level, it's rejected. They're rejecting the null. Okay? So it doesn't matter which way. You still have to find this purple z-score, whether you go by the chart or you go by the graph. Either way. All right. Number 10. An oceanographer claims that the mean dive of a North Atlantic right whale is 11.5 minutes. So again, 11.5 is equal. The null is going to be, the mean is equal to that. That's our claim. And the alternate is going to be the mean is not equal to that. Right? So we're going to find our statistic here, our z-score. So 12.2 minus 11.5. Again, it's always the sample mean minus the hypothesized mean divided by the standard deviation, square root of 34. Now, this is equal to 1.86. They're giving you a sample standard deviation. Sample standard deviation. So I have this wrong. This should be a T. The only difference, there's a T here instead of a Z, and that's an S instead of an omega. All right? So we can't compare this to our z-score chart. We have to go to our t-distribution chart. So when I go to the t-distribution chart, this is a two-tailed test because it's not equal to, which means it can be less than or greater than those extremes. So we go to our t-tailed test or t-distribution test, and we're looking at 34 samples. So our measure of freedom is degree of freedom is 33, and we're at 0.10. So two-tail, 0.10 and 33 is going to give me 1.692. So our critical value is 1.692. Okay, so again, here we go with my picture. My critical value is 1.692. By the way, it's also negative 1.692. And our rejection regions are here, both sides. Our t-score is 1.86, which is right here. And it's well within the rejection region, so we would say we're going to have enough evidence to reject the null. And since the null is our claim, we can also reject the claim. Okay. All right. A consumer group claims the mean acceleration from 0 to 60 is at most 6.3. So they're saying less than or equal to 6.3. So the null is less than or equal to, because it's got the inequality, that is the claim. And the alternate is it's greater than 6.3. So they give you a population standard deviation, so I'm going to use the Z formula. So 7.2 minus 6.3 over population standard deviation divided by the square root of 33. I get 2.07. So again, I like to do it by the curve. Doesn't really matter whichever way you want to do it. So I am at a z-score of 2.07. Where is my critical value? So the critical value is, the significance level is at 0.05, and we are going greater than. So you have to go to 0.95, which is 1.96. So 1.96 is here. So we are in the rejection zone. Okay, so you're going to reject. There's enough evidence to reject the null hypothesis and therefore the claim. There's enough evidence to reject the claim that is at most 6.3 seconds. Okay. Now, again, if you want to do it by the p-value, 2.07 greater than, so you have to go to 2.07, and that is 0.9808 on our chart. And you have to do 1 minus that. So 0.0102 is less than 0.05. So again, you would reject the null. So whichever way you want to do it, with the p-value or with the chart or the sketch, the graph, the regions, I do not care. Just show me your work so I know which way you're doing it. Okay? Pick one and stick with it so you don't get it mixed up. All right? So I will be at school in the morning, Monday before your test, so please come in and ask me questions if you have them, and we will see you then.